I'm doing standard one. It's my second video. Standard one, position, velocity, and acceleration, chapter 3, page 112, number 21. To get to a concert in time, a harpsichordist has to drive 122 miles in 2 hours. If he drove at an average speed of 55 miles per hour in a due west direction for the first 1.2 hours, what must be his average speed if he's driving 30 degrees south of west for the remaining 48 minutes? Question B, what is his average velocity for the entire trip? Here I drew a diagram, and this is the car driving from start. It travels the first distance of 1.2 hours. The velocity is 55 miles per hour, and the time is 1.2 hours. After 1.2 hours, he turns 30 degrees south of west. We don't know its velocity. We know that it's 48 minutes, and the time too. So we need the average velocity, and we need the distance, which is x1, and the distance of x2. First, we find velocity using v equals x over 2, so the distance x and time. Now you have x1 equals v1 times t1, and you plug in the 55 miles per hour, which is v1, times the 1.2 hours, and you get x1 equals 66 miles. Now to find v2, you take x2 over t2, and you know that x2, to find x2, we take dx minus x1, and our dx is 122 miles total, minus 66 equals 56, so x2 equals 56. 56 plus 66 equals 122. So you take your x2 over here, and you know what your time 2 is, which is 0.8 hours equals 48 minutes. So you plug in the 56 miles over 0.8 hours to get v2, velocity 2. Velocity 2 equals 70 miles per hour. Now for b, we want to find the displacement of the component x1, which is negative 66 miles, and the displacement for component y1 is 0 miles. The displacement for the component x2 is negative 56 miles cosine 30, and the displacement for y2 is negative 56 sine 30. So the x component of displacement is x equals x1 plus x2. x1 is 66 miles, x2 is 48.5. If you get the x2, the y component of displacement, y equals y1 plus y2. You plug in your 0, y1, and you plug in your negative 28 miles for y2, and you get y equals negative 28 miles. Now the x component of velocity is vx equals x over t. So you plug in your 114.5 miles over your 2 times h, 2 over 2h, which is 2 hours. And so your vx equals negative 57.25 miles per hour. Your y component of velocity is vy equals y over t. Vy equals negative 28 miles over 2 hours, so vy equals negative 14 miles per hour. The magnitude of the average velocity is v average equals vx squared plus Vy squared under the square root. So you plug in your Vx and your Vy, and you get the V average of 59 miles per hour. So the average velocity for the entire trip is 59 miles per hour.